Okay, since we have addresses and data, can we use a pointer to step through the variables? Answer is absolutely. We could actually use a pointer to do the same thing we just did with the index. Aha. So how are we going to use a pointer here? Well, remember, to use a pointer, all you have to do is declare the pointer and then assign it to an address. Okay. So we're going to access the array using a pointer. Okay, so these are fundamentals. So let's start with that. So remember, your array holds data type integers in it. So your pointer needs to be of the same type. So int, asterisk, and then call it whatever you want. I'm just going to call it PTR for now. Now, can I assign this pointer to the array? And the answer is absolutely. PTR equals my array, semicolon. And you're going to say, wait a minute, what is the end %? You don't have to. The name of the array is the actual address of the array, the initial one. Okay? As a matter of fact, if I printed simply my array, it will print the address where my array 0 is. Now, could I have done this? And % my array? Absolutely, but you will have to specifically say where. You will have to write it this way. Let's keep it this way for now. So we now know that the pointer is pointing to the first element within the array. Can we use this pointer to dereference by dereferencing it and seeing what the data is? Okay, well, let's start with the first one. So cout accessing the data in the array using a pointer. Okay, so that's the technique we're going to be using here. And we're going to do cout. And then I'm going to access the first data member, just show you how that works. And I could say my array 0 equals, and obviously I have a pointer. I need to dereference that pointer, so star PTR. And let's put an endl here. Right? End of line. Now let's see how this works. So right now I'm accessing only one data member of the array, the first one. So let's see if it actually will access it. Compile and run. And sure enough, as you can see, accessing the data in the array, let me fix that and my array 0 is 99. And sure enough, that's what we have. So let me fix this here. By assigning a pointer to the first element, that's what happens. Now, here's the beauty. You don't need to reassign the pointer over and over and over to each one. What you need to do is increment the pointer to move to the next element. You say, wait a minute. What do you mean by increment? You add 1 to the pointer. 1 of what? When you say 1 and it's an integer type that's stored in there, it's going to move by 4 bytes. Aha. If it's moving by 4 bytes, you have the resolution needed to move from element to element. So how do you do that? Well, you're going to increment PTR equals PTR plus 1. Now, the alternate syntax for this is simply PTR plus plus. You could do something like this. Okay? That would increment the pointer. But I'm just going to keep it this way. I'm going to write it formally. PTR equal PTR plus 1. That 1 that we're just adding in there, it's not necessarily adding 1 to the address. It's actually adding 4 to the address, since each integer has 4 bytes. Okay, so that's fundamental here. And let's see if we are indeed accessing the next element, which should be my array 1, right? So let's go ahead and do that. My array 1 equals, and all I have to do is dereference PTR, and let's see if we indeed accessed the next element in the array by simply incrementing the pointer. So the key here is we simply incremented the pointer. Now notice here, for me to read the data in the array, all I'm doing is dereferencing the pointer. Unlike the reading of the content with an index that I did prior to that. Let's see how this works. Compile and run. And sure enough, we have access to the second element, which is 78, by merely increasing the pointer by 1, which technically it increased it by 4 bytes. Since it knows it's dealing with a pointer of type integer, any incrementation is done by 4 bytes. That's your resolution. So can we continue with that and literally see what happens to the next element? So can we do the informal version of PTR? So yeah, you could do PTR++ right there. So you could use the formal incrementation by 1 in this manner, or you could do the informal version and then simply, so let me copy this several times, since this will be repeated several times to verify or to inspect the content of the array. So let me see here, how many times do we have? 1, 2, 3, 4. Yes. And the last time, I don't need to increment the pointer anymore because I've arrived to the last one. So this is 1, this would be 2, this would be 3, and this would be 4. Okay? Very good. So at the end, do not increment the pointer. You're going to be pointing down outside the memory space allocated for the array. Okay? So it's basically like falling off a cliff. You don't want to be there. Okay? All right. So let's compile and run this. And there you have it. So with a pointer, we were able to access the elements of the array by simply incrementing the pointer. So if you noticed, we have repetitive code going on. Either you use an index or you use a pointer. So for our next lesson, we're going to use loops to allow us to either populate the array, if you're populating the array in an orderly manner, which means you're starting with the first element to the last element. So it means you're not using any random access, which you can as long as you stay within the array. However, for the displaying the content of the array, we could literally have an orderly manner or method for accessing it through a for loop or a while loop. We'll do a couple examples like that to see how it can be done either with a while loop or a for loop to access the array. Okay, I will see you for the next lesson.